So again, good morning. My name is Durrell Rittenberg. I am the Director of Product Management here at Tecplot. And today we're going to talk about Tecplot 360. For those of you who have been to some of our recent webinars, some of the stuff I'm going to go over initially might be review. However, I think it's still pertinent information. I want to make sure that we talk about at least quickly prior to diving into a pretty reasonable explanation of the things that we're doing that are new. Some of the things that we're doing are under the hood, and so it's difficult to show, but hopefully you'll get a sense just by looking at the overall improvements we've made. So let's go ahead and get started. We have here, good thing just to remember, if you want to connect with us, please feel free to do so. We're on YouTube, Twitter, LinkedIn, and Facebook. So the idea is we're going to evaluate very quickly some of the trends that we're seeing. These trends, I think, are pretty common. We've been going to a number of industry symposium, and this seems to be very consistent across most industries at this point. And that is that there are a lot of things changing in computational analysis, and I'll make you just aware of some of the changes. We'll then focus our energies on what we've done to improve the performance of 360. And finally, we'll spend some time, and the bulk of the time we have together, going through some of the things that we've added to Tecplot 360 2012 R1. And again, as we go through, ask questions. When we get into the Q&A, I think we're a reasonably sized audience. If you have access to a microphone or telephone, if you raise your hand, I can go ahead and allow you to speak, and you can ask questions directly. And with that, let's get started. So this is something we've been talking about, I believe, quite often. And so for those of you who have seen this slide before, perhaps I'll just indicate that by maybe sharing with you a recent anecdotal story about this. Computational resources are pretty cheap, and a good friend of ours was talking to me about they took on a new position at one of the larger aircraft manufacturing facilities in the U.S. And they came in, and their primary background is optimization, and there was an empty office nearby. And they had a budget of like $100,000 for computational resources in general. This group actually went through and built out a pretty powerful cluster for less than $100,000 and put it in the office next to his main office. So you can imagine, of course, it wouldn't want to be in that office too often because it gets really hot, but you know, he was able to build a cluster that had a few hundred nodes in the office next to him, and he can start to run some pretty large models with that. And that's kind of what we're seeing, is these resources are cheap enough that for day-to-day engineering, people are running relatively large models. And not only are they running big models, but they're actually running a lot of models. And we've talked about this in the past, and I don't want to dwell on that particular point. I think it is worth just talking about why we're likely to see continued growth in data size, and in particular if we think of the computational mesh. So depending on the fidelity of the CFD run you're looking at, or the CFD case, you're going to be looking at very large grids. In fact, for RANs in particular, you're looking at 10 to the 9th grids required to fully realize a solution on the 747. I mean, that's a very, very large mesh. So we've got a lot of room to grow in this area. So it's unlikely in my lifetime doing this type of work that we'll ever get to the point where we have enough mesh. And if you go to some of the direct numerical simulation or large eddy simulation, I mean, you're talking about even larger amounts of data. And this is just gargantuan, and it's just going to continue to grow. We understand that, and that's, again, due to the scalability of these computational resources. So in that context, we've been working on performance since 2009, and I'm only showing one snapshot of this. And really, where we're at this point, we actually have increased the performance over 300%. This is only in 2009. I think the real key that we've been focusing on is data loading, which we understand at this point to be limited by disk speed and disk performance. Slicing and isosurfaces, which are more computational. Streamtraces and on-screen rendering, which is more around the GPU. So these are the things that we've been focusing on. And what we do now as a test is we are actually running a 1.2 billion cell model on Tecplot 360 on a daily basis, and we evaluate a couple of things. How long does it take to load in the data? How long does it take to generate geometries? How long does it take to interact and move the view around. And one of the things we've seen is a steady decrease. We're still in the 5 minutes to load 1.2 billion cells. This is unstructured data, but we're getting better. We think in the not-so-distant future, we should be able to get this under 3 minutes. So we're working on that. And again, our current constraint is reading off the disk. So we had a beta in April, and one of the key things we're going to talk about here is the 360 release that just came out last month, which the key features that we're going to talk about here today: automated stream traces, and we'll talk about how one can do that, constraining slices and slice groups. We've made some performance enhancements overall in the tool, as well as we've added the ability to load in ANSYS CFX data. So the ANSYS CFX data loader, now you can load in data from CFX. We've also done some improvements in Fluent. In particular, we've come up with a strategy to allow us to load Fluent data much more quickly than in the past. So that's been our focus. Again, getting data in, removing those pipeline constraints to improve overall performance with Tecplot 360. So at this point, I'm going to pop into 360 2012 R1. And we're going to walk through a couple of examples. I'm actually going to highlight some things that we added in a couple releases ago as well, as I think they're pertinent to this discussion. Also, it's important to understand that we've made some improvements, and I'm not sure everyone knows about the things we've done. So to begin with, I'm going to load in a data file, and we're going to talk about slicing and slice groups. So I'm going to load a layout, or actually I just load a data file, really doesn't matter too much. And you can see that we have a number of different data file formats. The one that I'm going to load in particular is going to just be Tecplot format. And the data, or actually the data that I want to look at is on the desktop here. So we're going to evaluate some results, and actually I guess I can go right here, and we'll just grab one solution, and we'll open that up. So this data is 3D. It's a simple UAV. Some of you may have seen this case before. Okay, so this is the simple model. Now, a couple of things that we've changed just in terms of how the data looks at. I'm going to talk about slicing. And one of the problems we ran into in slicing is this problem, which is that basically, and this one's relatively small, but the domain is relatively large compared to our vehicle. And this has led to people getting pretty sophisticated in how they show stuff. In essence, what we saw in the real world is a lot of people were trying to do stuff like this, where they would really kind of zoom in and use a different perspective because they wanted to be able to identify or isolate pieces of a slice near the object of interest, whether it's just around the inlet or whether it's around a wing like I show you here. So one of the things we wanted to do is make this a little easier for doing that kind of analysis, especially if you have a large flow domain. And to do that, what we've implemented is what we call a constraint. So we use a slice constraint. And you can see that it's basically a box that you can interactively change. So in this case, I can change how big the slice is. And I can identify within this box now, this is my constraint. Now you can see that my slice is right now in the Y or X direction, but if I put it, say, in the Z direction, or in the Y direction, or in the X direction, you see it's still constrained in my box. So this is part of what we've done is to make this a much easier process so that when you evaluate that solution, you can actually walk through a slice on the body, as I show you here. Okay. So that's one of the things we wanted to do. Now, once you have a slice like this, we actually implemented something that you can use this now to generate stream traces in the flow domain. So I'm going to extend on this, we're going to generate some stream traces. Now, we added in the capability to launch those stream traces in a number of ways. So initially, what we've done in Tecplot 360 is had the ability to basically just draw on an object and create stream traces, and this would do 10 at a time effectively, as you can see. But that's not really effective if you're trying to understand the flow around the body of this vehicle. You don't want to do this one by one, so we implemented a strategy that allows us to do this in a more automated way. So we're actually going to use an object, and the object in this case is the slice. So I'm going to select the slice, and I'm going to release say 150 stream traces on this slice randomly in both directions. And if I hit create, you can see that what it does is it's going to create 150 stream traces randomly, although it's going to take into account the mesh size so that it tries to put more of the stream traces where there's more mesh. So as you can see now, we can put in 150. From a performance perspective, we've actually done some things to make it much faster. And just to give you an idea, I'm going to go ahead and generate, say, 1,500 stream traces, same thing, and hit create. You'll see that it just takes a few seconds. And now we're looking at 1,500 stream traces. This model's a little over 1 million cells, so this isn't a huge model, but you get an idea of how this can be very useful to analyze a system very quickly. And of course, as is part of Tecplot, you can do this in an automated way using macros. So that's a couple of the key things we've added. I want to actually load in a different model, and we're going to evaluate that model in the context of stream traces on a surface, which is another typical use case. So let me go ahead and load those data. Those data happen to be in Plot3D format. In the last couple of releases, we have made significant improvements to the way that we load Plot3D, including allowing for people who are doing overflow and doing unsteady results. If you're looking at an overset grid type, we can now have a non-uniform grid structure, and that would allow you to have, say, look at something that's time-dependent where the grid is changing because you may be resolving features in the flow field. But the model I'm going to look at isn't all that interesting, so we'll go to that quickly. And again, if you have questions on anything you're seeing here today, do me a favor and go ahead and type those into the Q&A dialog on the side. Okay. So let's quickly open up the simulation data. We're going to evaluate the simple Onera delta wing, which is a typical test case. And we're going to bring in just first the grid. And let's go ahead and grab the solution file as well. And I think we have a name file, so I'll grab that as well. Okay, so we're going to bring in the M6 wing test case. And that's okay. So we're going to go ahead and load this in. So here's the wing. It's a relatively small case. A couple of things that I get a lot of questions on when I'm out talking to customers is around axis of orientation. The rotation axis is typically at the center of the overall flow domain. If you want to change it, you just put the mouse where you need it and hit O. Doing so will reset that orientation axis and allows you to more quickly evaluate the system. By now you can rotate it around a given point. And I do understand that the audience you view is going to update a little slower, so you may not see me doing that in real time. But let's talk about stream traces now. In this context, same thing, we're going to look at stream traces. Now, in the last time I showed you, you can actually seed those stream traces based on a slice, and we'll actually do that here in a second. The other thing that you can do is evaluate surface lines, and in this case we just want to look at the wing surfaces. So you can see that my domain actually has the wing surfaces upper and lower as subzones, and I'll actually just activate those quickly. So we're just looking at the wing surfaces here. And what I'm going to do is use surface lines, and I'm going to use the active zone. So I'm going to use the 2 zones I have active here. Same kind of thing, we're going to look at 1,500 of these, and I'll go ahead and hit create. And what it's going to do then is generate 1,500 stream traces on the surface of this wing. So you can see that they've been randomly put on the wing. Again, it's trying to take advantage of the overall grid density. A couple of things to point out. It helps you identify areas of separation, like you see in this area. So that's actually an area where we've made an investment to make this type of operation much more facile. And I'll delete all of these temporarily. And we'll go back to slicing for a moment, and I want to show you some things we've done around slicing. In particular, I'm going to show you a couple of things on Fluent. And there'll be plenty of time for Q&A, by the way, so if you have questions, please go ahead and type them in as we're going along so I can make sure that I answer them. It looks like we have at least one question waiting, so let me open this up. Okay, nice. Hey, can you release one stream trace directly on a node or cell center? The answer is sure. And the way that you do that when you're doing stream traces and you do the point, if you hold Control, it will actually select the nearest point as a launch. So you can think of it as it will grab a node. If I turned on the mesh, you can kind of get a sense of it. So when you hold Control in Tecplot, it actually will snap you to a node. And we'll use that node as a launch point. Okay, cool. With stream trace generation from constraint slice, are the stream traces also limited to the constraint box? The answer in this case is yes. So if you constrain the box, you're going to be constraining the stream traces in that box. Right now, the way that we're doing it, it's more or less random. However, we do have a number of people who have suggested that we give you a little more flexibility in how you present the stream traces on that slice, and it is in the backlog that we'll be working on it. But right now, one of the big improvements is just being able to do it on that slice as well. And then there's a question around 3D mouse for Tecplot 360. Today we're aware of that technology. We have not implemented a 3D mouse, and be very interested in learning more about why you want to do that. Okay, in generating stream traces on a wing, the vectors has momentum. However, the streamlines were generated. If the solution were viscous, then there would be any stream traces, which is true. How would you do that streamlines on a viscous surface? You know, there's a number of ways depending if it's structured or unstructured. You know, in this case, we actually do have a boundary which has, in effect, it's like a K1 or not the K1 plane, but the K2 plane. So, Andrew, I'll follow up with you. It depends on how you're writing out your data, but there's a number of strategies to impart the velocity onto the surface for surface streamlines. So, okay, good questions, Owen. Keep them coming. All right, we're going to go ahead and go to a new layout, and we're going to bring in some Fluent data, so I'll load that in. And the data set in particular that I'm going to evaluate is really around a land speed record. So this was, in effect, it's an automotive example. And I'll just look at one of the higher speed models. And this is a simple case and DAP file, and I'll add them in. Now I'll go ahead and open these files, and we'll go ahead and load them directly in Tecplot. So one of the things that's happening now that's different than it used to be is that when Tecplot 360 loads Fluent data in particular, the first time we load it, we actually create an index file. And you can't see it here, obviously, but let's go ahead and look in that directory. I just want to show you where that's showing up. Now, this index file allows us to load things much more quickly. And I'll go quickly to that folder, and you can take a look at what we're talking about. So Tecplot derived, you'll actually see there are these files which in effect are index files. Now the reason they're there is to make it faster to load the second time. So the first time we loaded this, it took, oh, I don't know, a few seconds to load, maybe 20 seconds. We're going to go to a new layout, and we're going to go ahead and load the same data file again. So we'll go to load data file, same thing, same file, everything's okay, and we'll load that in. And in principle, the way that this works, you can see the data is already loaded. All it's really doing is auto redrawing. So it takes just a few seconds to load. Okay. And where this becomes really helpful is when you're looking at very large files. Now this particular file, if we go take a look at, isn't overly large, and I'm doing this on my desktop or my laptop. So if we just go to the data set, we're talking about 4 million elements, about 1 million points, so pretty small. This becomes really critical though when you start looking at 30 or 50 million cell models, because then loading can take longer. So this will certainly make it easier. So I'm going to make this a little easier to see by deactivating a couple of surfaces. From an overall standpoint, we're going to talk about using constrained slices here as well. But while we're doing that, we're also going to take advantage of clipping. And so I'll show you a little bit about that as well. Now, I bring this up because when I've been out on site talking to people, I've noticed that most people still aren't familiar with what we've done in the context of surface clipping. So I want to just show you, this is our typical slice, and you can see where it is in the domain. And you'll notice that there's two things. We have the position. One thing you can do with position, I'm going to make this a little easier to see, is use clipping. So you can clip either above the primary slice or below. Now I'm thinking this is going to be below, but we'll find out in a second. If I wanted to clip out everything above this or below the slice here, I can turn on clipping, and I guess it was 50-50 shot. There we go. What you can do is actually clip everything off, and you can see that that domain is now, or that data is now being clipped. Okay, and if I turn on a second slice group now, you notice that the slice group is actually following the clipping. But you do have the ability to say, well, you know, I don't want to obey clipping. I can turn that off. And in essence, you can start to clip off pieces of the geometry while still looking at slicing in other directions. And that's something we added about a release and a half ago, sorry, 2 releases ago. And a lot of people just aren't aware that that technology is available. And you can have up to 8 constraints, as well as, or up to 8, in this case, we're talking about clipping modes. So you can really kind of dice or slice and dice volume pretty well using that strategy. And it does behave in the way that you would expect, in that you can clip interactively. So if you wanted to, say, clip a component of it. Okay. And someone asked, does loading transient Fluent data get faster as well? Absolutely. When you load in, again, the first time we go through it, we're adding that index, but if you're looking at unsteady results in Fluent, once the index file is available, it's much faster. And I don't have a good example I'm going to show you on the laptop, but we'll kind of get there in a second. Okay, so we're going to then apply our constraint much in the way we did before. We're going to apply a constraint to, sorry, not this one, but to the second slice group. Okay, so there's our constraint, and before I talked about just how do you make the box bigger or smaller, what have you. In this case, I'm going to show you that you can move the box in 3D as well. So like in this case, my constraint didn't do a very good job because in fact my slice isn't even on the body. So then based on that, I can increase or decrease the Zmax to kind of bring it down on the body. Okay. So similarly now we have this vehicle. If I want to do stream traces on the surface here, assuming it's not going to be viscous here. We'll find out in a second. I believe it's not, but I'm going to use the selected zone. So I'm going to select an object, in this case the surface of the body of the vehicle, and I'm going to create, just so we don't have to wait around too much, let's just do 100 of them, and we'll hit create. And that's going to be volume lines, and I'll delete all those. Got to make sure that I select surface lines. And do that again, and we'll hit create. And what it's going to do now is apply those surface stream traces, and again, depending on how much recirculation it's going to. Okay, while it's doing that, we'll pop into one additional example. So I've kind of talked about some of the loading capabilities. I've talked about the constraint slice. I've talked about improvement, things around performance on larger data. And we're going to start by loading in a data set that's from my laptop, 30 million. And I run into this somewhat often where people say, I try to run Tecplot on 30 million cell models and I just can't do anything of interest. So I'm going to go ahead and load a data file. In this case, it is a Tecplot data file format. And the data, again, I just put it on my desktop. Look at it is just a simple space shuttle, and it's about 28 million cells. I'll go ahead and grab that here. I can just say, hey, show me the first zone only, and then in which case, after it goes through and indexes what's there, you can see it brought in the one zone. The data set itself, if I go to data set info and take a look at the data set here, we're looking at 28 million points, 26 million elements. So let's go ahead and apply a style to that. For those of you who are familiar with our strategy of using style files, I'm going to load in look and feel information and just apply it. And all that really is going to do is it's basically going to say, okay, it's going to apply look and feel information to all the zones, and I believe in this case it's going to turn on the surfaces. Now, in this case, it also will load in at least one variable, so it slows it down just a little bit. So there is the model. Again, you can see the number of triangles on screen is much higher than if you turn on the mesh. You can see that it's a multi-block model. It's a relatively highly refined mesh. And we're going to grab a slice and just show you what the slice looks like. And again, the slice is going to have to pull in the data the first time, but then the slice interaction, I think I've shown this data set before, it's pretty fast. So, okay, so we're just looking at overall pressure. and I can move that now interactively, and you can see you have very good on-screen performance. If I want to do, say, stream traces, and again, this is a much larger model than we showed with the 1 to 5 million cell model I showed you a moment ago, we can actually look at stream traces very quickly from this slice as a seed point. And I want to show you while we're doing that the performance of Tecplot 360, so hopefully we can make enough space on the desktop so you can see both. Okay. All right. So we're going to grab stream trace, and we're going to generate, say, 10 down here. And you can see the second I do that, Tecplot is going to take advantage of all of the processors I have available on my desktop. In this case, it's a laptop. Now, you'll see that when it's done, though, it lets go of the processors so they can be used for something else. We're really trying to be efficient with how we use this data or how we use memory on the desktop, so that if we don't need the processors, we're not going to use them. And I suspect this guy's probably done. Yeah, so you can see it actually found some area of recirculation somewhere. So you can see it did finish, but we'll go ahead and close this just to alleviate some of the resources on my machine. Let's go ahead and just generate a few more stream traces so you can see just how fast this is. And heck, let's take advantage of our new strategy, which is to use the slice to do a series of random stream traces. So we'll delete all of them. And we're going to go in and use an object, the object being the slice. And let's look at, say, 1500. So this is a pretty heavy test. Just for clarity on my machine, what we're looking at, and I think you can do this under properties somewhere. Okay. So this is my machine. I have it's a quad-core machine. I have 8 gigs of RAM. And I don't know where it has the, it actually has I think it has a NVIDIA to-go card. It's not a bad card, actually, so it's a reasonably powerful machine. Okay, so now we're looking at this object. We're going to do 1500 stream traces, and we're going to create. Look overhead. You can see CPU usage just went way up as doing the calculation. And it's maxing out the machine. You can see how much memory is being used. And we're looking at doing 1500 on, nominally 30 million cells, so not a speed. Okay, we've had a couple people chime in terms of they've already downloaded the new beta or the new machine. Okay, well, there you go. So, it took on the order of 35, 40 seconds to do the overall draw here. You can't see them too well because they're black, but let's make them white. Redraw them here. So that's 1500 stream traces in our domain. You can see on-screen performance is pretty snappy. And that's, again, due to the focus on making Tecplot 360 faster. So, okay. So a couple of more things, and then we're going to open up to Q&A. And the last two things I want to talk about very briefly have to do with just animations in general. And I know that I've shown many of you this before, but I want to talk about how we've improved animation, and we have done some improvements in terms of the overall output formats. So we're going to do a keyframe animation of this model, and we're going to append a couple of views here. So this is the main view. Let's kind of zoom in a bit. Append, and we'll append a couple of these. And we'll append this as well, and we'll append that as well. So we've now basically added in, see, there's 30 steps each, so quite a few. And if we just animate this on screen, you can see that all it's really going to do is update the position. So let's see while it's doing that. Okay. So it's going to walk through each one of these, and we're looking at, 6 times 3, so 180 or so snapshots. So you can see as it goes through, you can see the progress down here. It's just rendering everything, and it's actually using all the processors on the machine. I'm going to stop this because that's actually not what I wanted to show you. What I did want to show you, of course, is that, well, actually, just for speed, we'll remove these guys. And we're going to animate these to a file. And we had lots of people asking for different file formats. And one of the ones that came up a lot was MPEG-4. So we implemented an MPEG-4 video output. And so I'm going to actually create this using the data that we have here. I'm going to go ahead and optimize this, and I'll put it out on the desktop and use a strategy node to delete. And we'll go ahead and hit automate. And so now you'll notice that it isn't actually rendering on screen. We do off-screen rendering, which is great if you want to run this in batch mode. So a lot of times when you have large models, you don't want to do this interactively, and this will allow you to do that. And so what it's going to do first, it's actually going to generate all the images, and then it puts them in more or less like a temp file, and then we have an algorithm that will take those and put them into MP4 format. Okay. All right, while it's doing that, I'd like to get everyone to perk up. We're now going to go into the Q&A session, and for this type of meeting, I usually get some pretty good Q&A. So if you have a question you wanted to ask, please go ahead and either do one of two things: either type the question into the questions dialog, or as an attendee, all you have to do is raise your hand, and I can unmute you, and you can go ahead and ask a question. So if you have your hand raised already, go ahead and see. I'll go ahead and start that in a second. Okay, so it looks like it's done. We're going to pop into the desktop here very quickly, and let's take a look at our file. And I guess it's going to open in QuickTime. And while it does that, see which monitor is it going to open on. As I often joke, I guess I just didn't click hard enough. Oh, and maybe I should close out some of these things. So, okay, there we go. So as that comes up again, if you have any questions, go ahead and type them in. And there's the QuickTime viewer. Oh, I guess I opened it twice. All right, and if you hit play, you can see there's the animation. Nice high quality. All right, let's go back into PowerPoint, and I'll summarize, and we can open it up to Q&A. So we're going to continue to improve Tecplot 360 performance. Our current version is an order of magnitude faster in a lot of things, and several orders of magnitude faster for some things than Tecplot 10. And we've made a lot of strides, so if you haven't upgraded, do us a favor. Please go to the website. If you're under maintenance, you can just download the new executable. Performance is now comparable or faster to most tools on the market. We've done some internal and external testing, and Tecplot 360 performance is pretty much comparable. And I think we're all running into the same problem, in that reading data off the disk is a real issue. And because of the way that we've implemented Tecplot, it's much more efficient. It doesn't lock up unnecessary resources. And I wanted to thank all of you for sitting in, and we're going to open it up to questions, but I'll leave you with upgrade to Tecplot 360 2012 R1 if you haven't already done so. Okay, and let's go over. So if you want to raise your hand, go right ahead. I have a couple of questions here. What is the best way to incorporate a solid-state disk to minimize file load times? John, that's a great question. One of the things that we've been toying around with is something called a Fusion I/O card. It's a group here locally, and it's basically a way to approximate memory. It's almost like you have going to have 10 gigs of RAM instead of having 5. Or is that right? Gigabytes of RAM? That's right. It's like adding hundreds of gigabytes of RAM. So it's using a similar thing to a solid-state disk. Solid-state disks are certainly a great way to go. They're just very expensive. So if you can bring the data local on a solid-state disk, you're going to see an increase in performance. There's a question around, can styles be used in layouts containing multiple frames? The answer, John, is no in that case, because then you'd use a layout. See, a style is kind of unique in that style only has look and feel information. It's data agnostic. Layouts have data, look and feel information as well as links to data. So when you use a layout, you in effect have many style files and links to data. What you can do differently with that is you can rewrite what data is used. So you can use a layout, overwrite the data, much the way I showed you with the style file. Okay. If you want to go ahead and raise your hand, I'll go ahead and call on you. And it looks like, Andrew, you have your hand raised. I'll go ahead and unmute you. Andrew, good afternoon.
Hi there. Thank you. Actually, I'd already asked the question. I guess I typed it in and clicked on that button previously. Thank you.
All right. Thank you, Andrew. Let's go to, see, Kendall. Kendall, I know you asked a question as well, but I'll unmute you. Kendall, did your question get answered? Do you feel like? Kendall Dennis? Okay, well, it may be that he doesn't have a microphone because it looks like he's using a computer. Do I have to load the whole data set once or just one time step? That's a very good question around the, I believe this is in regards to the Fluent improvements. You're going to have to load, you're going to have to load the whole data set at some point to get the indexing file, because that's just part of the load strategy today. So today that's the way you're going to have to do it. Okay. It looks like, let's see, I'm not even sure how to pronounce that one. Atita, you had a question. If you want to go ahead, I've unmuted you. You're more than welcome to ask that now. Okay, it looks like you also have it's a microphone problem. There's a question around the indexing strategy and whether it's only for Fluent data today. Today, I believe it's only Fluent data. However, we are planning on applying that strategy to things like CGNS in the future. It's on the backlog, and hopefully we'll have a beta with that in it pretty soon. We'll see. Okay. Okay, other questions? Linda Hedges, who's had to leave, but said that she's downloaded it and already saw these improvements and was very happy to see them. We'll open it up to, say, one or two more questions, and then we'll kind of wrap it up. Okay, there was a question on just our growing database of data file formats, and in particular around CFX. We added CFX loaders, so I think at this point, if you have CFX data, you should give it a go. The performance is pretty reasonable, and it doesn't have the indexing strategy just yet, but we're working on it. Someone asked about the video quality. The video quality on my side is not choppy at all, actually, and that's it's a function of the technology that we're using. So whereas this is I guess 60 frames in 1 second here, what you're seeing is probably every 10th one. So it's perhaps less to do with the video itself and more to do with the streaming technology we're using for the webinar. We have time for just one more question. Okay, there was some questions about, okay, there's a question about the overall performance improvements and where we're going with client server. Good question on that. We've had quite a few people ask us about client server technology, and one of the things that we're seeing is that moving forward, client server technology may morph into something that's more less seamless to the end user, where it's more like virtual environments and more cloud-based. Provided that we start going that direction, client server may be a technology that just isn't around 10 years from now. But it is something we're looking at ways to speed up what we're calling large remote data visualization, and that includes a strategy that we use called VDI. It's a virtual desktop environment, and I'll see if I can minimize this. What you're looking at is a system that I'm running out on my remote server, and this is a very fast machine. And what you see is that we actually have very fast on-screen performance, even though this is virtual. So in essence, this allows me to run as if I'm there. And I think HP has another strategy. HP uses the HP Remote Graphics System. That's another strategy. Again, it's more virtualized environment, and that seems to be very fast. Okay. How many megabytes or gigabytes is the 1.2 billion point data set that takes 5 minutes to load? I think it's on the order of 5 gigs. Tom's here. I think you might be able to. I think it's close to 5 to 6 gigabytes of data, but I could be wrong by an order of magnitude, so it could be 50. Scott Emily, who actually is traveling today, was supposed to be here. He would know a little better than me. So, okay. Okay, well, if there are, in the future you need better Python capabilities. We did update to Python 2.7, but we're evaluating how we use Python and seeing if there's a better way. I agree with you, the way that we do Python today, debugging can be kind of complicated, so something we're aware of and trying to put some resources behind. Well, if there are no additional questions, I will go ahead and thank all of you for sitting in today, and encourage you again, if you haven't already done so, to follow us on Twitter if that's something you're doing, or if you'd like to see some videos showing some of these new capabilities, we've posted those out on YouTube. We're also on LinkedIn as well as Facebook. Thank you very much for sitting in today, and the recording of this webinar will be available probably by this afternoon. You will get an email telling you when it's available. And with that, I will thank all of you for your attention this morning, and thank you and see you at our next web event.